I think there's a lot of taken on trust and on what the teacher says when you talk about combustion. So demonstrating that how the water is produced, and the only thing that is actually happening is something is burning. So you can actually show the water levels increasing and show that the carbon dioxide level is increasing and showing the oxygen level is dropping is a really crucial point. And then they start to appreciate looking at a graph to see how things change, that if it's going up, it must be being produced. If it's going down, it must be being used up. So they start to now appreciate what a chemical reaction is, what reactants are, what products are, even if they don't fully understand all the language we would normally use when we're talking about science. So that's the benefit of using the data loggers. What I'm going to do, we're going to talk about today reactions. Now, when we talk about reactions, we're talking about chemical reactions. I am going to do a reaction here, slightly different from normal, but it's the same kind of idea. I'm going to make a cup of coffee. So, to have a cup of coffee, I've got my hot water, my coffee, my milk, because I'm sweet enough, I don't take sugar. I'm going to add my coffee. Okay, there's coffee granules going in. I'm going to add the water. And then, finally, give it a stir. I'm going to add my milk. There we are. Now, I have taken coffee, milk, water, and I've ended up with a cup of coffee. But that is a combination of all the different things that I started with. Now that's very much like what a reaction is. You take things on one side, you mix them together, they join in different ways, and you end up with something totally different. Okay? So in this way is like a reaction. Okay? So you've got to hold on to that thought, because today what we're looking at is a particular reaction which is called a combustion reaction. Now, has anybody heard of the word combustion before? Fantastic. Okay, Kieran.
Is it like gas and then it ignites?
Well done. Well done, Kieran. That is absolutely right. It is like a gas and it ignites and it burns. So thinking about that, we have gas which it ignites and it burns. Does anybody know any other combustion reactions at all?
The combustion engine.
The combustion engine, well done. Where do we have a combustion engine, Zach?
In cars.
In cars, brilliant.
Cars.
Absolutely right. Okay, we have combustion engines in cars. They are there to make sure that we can use the fuel and we can drive the car. Okay? And that's what we're going to be talking about today, is combustion reaction. It's a reaction. We start with some things and we end up with others. Now, thinking about what I've just said, we start with one thing and we end up with something new. Can anybody look at the kind of sentences? I've broken it up a little bit here. I've taken a sentence and I've chopped it up. Is anybody brave enough to have a look at these sentences and actually place them together to make, because our part sentences make one complete sentence, to describe what we mean by a chemical reaction? But before you do that, just remind you, I took three separate items here. I mixed them together, they reacted, and I made something new. Okay? Taylor, would you like to come out to the front? There you go. Well done, Taylor. Brilliant. Just put the pen down. That's fantastic. So we have, when different chemicals are mixed together and they react with each other, they form new chemicals using up what we started with. Okay? Fantastic. Okay. Well done. So, what we're looking at is I want you to be able to explain to me what happens when we carry out a combustion reaction. So we're going to start with some things. We're going to react them as a chemicals, and we're going to make something new. Okay? Now, I don't know how much you know about these types of things. It depends what you did in your primary school, but we'll see how much you do know about combustion and what type of things we make. So here I have a candle. And all I need to do is give this enough energy to get it started, and then it will keep going. Now, you've probably never appreciated it before, but that is a combustion reaction. I am taking the chemicals from the air, the chemicals inside the wick, and I'm reacting them together. What I needed to do to get them started, though, was give them a little burst of energy at the beginning. Okay? So we have a combustion reaction happening here in a candle. Right. So, in fact, to burn anything, you need three things to burn them. Let me give you a little bit of a hint. We have our candle wick. We have the oxygen we breathe. And I also lit a match. So what three things do we need in order for us to have a combustion reaction? Jack, what are these three things?
They're fuel, oxygen and heat.
All right. So we need fuel, oxygen, and our heat source. Now, if I blow this out, you'll probably see a few things come off. Okay? So what is being released when we actually burn things as combustion? Any suggestions? Kieran?
Smoke.
Smoke. Okay, we're getting smoke coming off. Has anybody got any idea what that chemical could be that's actually giving off in the smoke?
CO2.
Well done. Okay, it's CO2. Who's heard of CO2 before? Put your hands up if you have. Is anybody here responsible for releasing CO2? In fact, you're all responsible for releasing CO2. You're doing it right now. Just put your hand in front of your mouth. Blow. What can you feel? More one out.
Is it carbon dioxide?
It is. Well done. Okay, it's carbon dioxide. Absolutely. Okay, so we have combustion reaction. We're getting an idea now. There are chemicals involved. Has anybody got any idea what chemicals involved? Remind me again, because I've got a bit silly in my old age. Yep.
CO2 and oxygen.
And oxygen. Okay, so we know CO2 is something that is involved. We know oxygen that's something involved. Just do me a favour. If I tell you that you are actually producing the products, the things that you make when you burn things, put your hand in front of your mouth again, blow, and tell me what else you feel. You feel the air, but you feel something else. Think about that. Megan?
It kind of feels like kind of wet and stuff, doesn't
Well
it?
done. Okay, so what would the wet be, Megan? It is what you think it is, as simple as you think. What is moisture?
Water.
Water. Well done. Okay, it's water. So we've got carbon dioxide, we've got oxygen, we've got water. Okay, all these things are starting to play into this now. In fact, to get the idea across of that water is actually produced, you would need to actually go onto the chemical formula explaining how you got the carbon and the hydrogen in the hydrocarbon, and how the hydrogen then will react with the oxygen in the air to form the water. Now, that takes you up to GCSE, post-GCSE level kind of chemistry, and appreciation of conservation of atoms. And until the year 9, we wouldn't even get that far. So to do this with year 7s means they're already starting to appreciate that water is produced. We know that because we can see the sensor detecting water, and the only thing that's happening is the combustion inside the chamber. What we've got here, inside this jar, this is called a bell jar. It's called a bell jar because of the shape. We have in there a thing that detects water, a sensor which detects oxygen, and we have the sensor at the bottom which detects carbon dioxide. Now, what I'm going to do in a minute is I'm going to place this candle inside the bell jar. I'm going to light it, and then I'm going to close it off. I'm going to turn the computer on, and the computer is going to plot for me how much oxygen is in there, how much water is in there, and how much carbon dioxide is in there. And what you're going to have to do is you're going to have to use the graphs to tell me which one is being produced, which one is being used up, and those type of ideas. Okay? So you've got to use the graphs. That's the key thing here. Right. So I'm going to connect these sensors up first. So, first of all, I'm going to attach my oxygen sensor here, my CO2 sensor, and my water sensor. We now have the amount of CO2, the oxygen, and the humidity will tell us how much water there is. Okay? Now, does anybody know how much oxygen is actually in the air we breathe? Zach?
Is it 25%?
You're not far off. It's actually 21%. So, when I start this off, the oxygen sensor is going to pick it up at 21%. What do you think is going to happen to the amount of oxygen inside this container? Bearing in mind, no air can go in and no air can go out. What's in here stays in here.
Or decreases the candle burns it up.
Well done, Zach. Okay. So when do you think, at what level, in terms of percentage, we start at 21%, when do you think the actual candle will go out?
15.
15. Okay, that's a good guess. I like that. Okay, here we go. I'm going to start it playing. So our carbon dioxide is not changing, our water is not changing, and neither is our oxygen. Okay, staying the same. So I'm going to put the candle in. I'm going to watch what's happened and see if you can use very quickly the ideas of what happens with the graph to explain what is going on. Okay? So what's rising?
The blue.
Moana?
The humidity.
The humidity. Good. What's that detecting?
The water.
Thank you, Cameron. Okay. So we are detecting water. What is happening to the amount of carbon dioxide inside the bell jar?
It's increasing.
It's increasing. Thank you. So the carbon dioxide level is going up. The oxygen level is going
Down.
down. Thank you. Okay. So the oxygen level is going down. The humidity's gone up high. Look how high the humidity's gone. So what does that mean we are using up? Moana.
Is it the oxygen?
Well done, Moana. It's the oxygen. What are we producing?
Is it carbon dioxide?
It is. Well done. And what else are we producing? What else are we producing? Think about what's the other one that's gone up?
Is it the humidity?
Humidity. And what does the humidity detect? You drink it?
The water.
The water. Thank you very much. Okay. I know the candle's gone out. Okay, thank you. Difference is before you would have said, all right, let's put the candle in, and you would have let it go, and you would have said, why does it go out eventually? And you would have come round to the decision that eventually the oxygen runs out. And then they would pretty much, and it's a huge misconception, they would believe it would go out at 0%. But in fact, it's only around about 17 to 16% that the oxygen level goes to when the candle will go out. And they don't fully understand that at all. So that gets over that misconception. But for them to actually see the level going down itself, and they can see upon the reliance, and also as the flame gets smaller and smaller and smaller, they can see the oxygen levels getting lower and lower and lower. So they get to appreciate that we need 21% or above for efficient combustion to happen.